Okay, my dear students, so let's start with question number 6 now. What is the question number 6 asking us to do? See, question number 6, prove that the ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding medians. See, basically this is nothing but what I had told you when actually speaking areas of triangles are similar. This I had told you when actually areas of triangles are similar. Sorry, when triangles are similar, triangle 1 is similar to triangle 2, then area of triangle 1 upon area of triangle 2 by ratio of areas of similar triangles, we get definitely the side 1 square upon side 1 dash square will be equal to side 2 square upon side 2 dash square will be equal to side 3 square upon side 3 dash square, and it will be also equal to median square upon median square dash square. Of course, perimeter upon perimeter dash square also will be there. Height upon dash square also will be there. This is definitely there. But now they have asked you to prove that the medians are also, corresponding medians are also in proportion. That's what they are asking us to prove. See here, what are they telling? Prove that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding medians. Means basically there are triangle like this, one triangle and the another triangle. And then there are the medians over here. Median means it will go and connect to the midpoint of the opposite sides. Midpoint of the opposite side. This is ABC. This is PQR. This is D. This is S. This is a median, and this also is a median. Therefore, D will be the midpoint and S will be the midpoint of the corresponding sides. Now here in given what you will have is definitely triangle ABC is similar to triangle PQR, that is given. You can see ratio of areas of two similar triangles. So similar triangle is given is equal to, means now we have to prove, of course, but then median also you have to write AD and PS are medians. Fine. And to prove what we have to prove, ratio of areas of similar triangle is equal to the square of the ratio of their corresponding medians. Means area of triangle ABC upon area of triangle PQR will be equal to the square of the corresponding medians, means AD square upon PS square. Is that okay, my dear students? So we will get what? Proof. Of course, this again is very simple, my dear students. Actually, ABC is similar to PQR is given to you. You have to convert it to ABD similar to PQS. That's all. Once you show these two triangles are similar, then you will be able to show the proportional over there. Okay. So here what we will get. See, to show it similar to, definitely because triangle ABC is congruent to triangle PQR, so these angles will be congruent. Now only thing is that this upon this is equal to BC upon QR you have got is equal to BD upon QS we have to prove. And I think if you have done your previous questions properly, you will be able to understand how to do that. So here we have given triangle ABC. You should be able to visualize this, my dear students. Actually speaking, you should be able to make diagrams. See, if you want, I will ask you, see here, what will I do? See, this is given to me. So basically, see, this is very, very, very important, dear, my dear student. Don't ignore this part. Don't ignore this part at all. Otherwise, see here, A, B, C, P, Q, R. Actually, this is I have got. These are similar. Because these are similar, therefore these angles are congruent I will get. And this upon this, I will have to convert AB upon PQ. Actually, I have got BC upon QR. This I will have to convert to BD upon QS. BD upon QS. This I know you should be knowing by taking half over here. BD upon QS. You should be able to convert to BD upon QS. So then afterwards in this triangle, you will be able to prove AB upon PQ. This is A, B, C, P, Q, R. AB upon PQ is equal to BD upon QS, because this you have proved that they are congruent. BD upon QS, and these angles are congruent also you have got. Therefore they will be similar. And then AB upon PQ is equal to AD upon PS. See my dear students, you will be able, this you should be able to see properly. Now what I have got triangle, so I have come moving from here till here. I hope you all have understood over here at least. Triangle ABC is similar to triangle PQR. This is given. Therefore, first of all, angle ABC is congruent to angle PQR, corresponding parts of similar triangles. But definitely angle ABC congruent to angle PQR is not needed. I will be reading angle ABD congruent to PQS. Therefore, angle ABD is congruent to angle PQS. Same angles, different names. Fine, this is your one. Also you will get AB upon PQ is equal to BC upon QR, right? AB upon PQ will be equal to BC upon QR, because corresponding parts of similar triangles. Then what you will do is that AB upon PQ is equal to, this is BC upon QR. You will take half of this and also half of this. Fine, this is your second. But half of BC will be equal to BD is equal to BD, and half of QR is equal to QS. Both reason is property of median. Fine, this is your 3, this is your 4. From 2 and 3, 4, we get what? AB upon PQ will continue over here. Instead of half of BC, I will write BD. And instead of half of QR, I will write QS. So I have got now AB upon PQ is equal to BD upon QS. And of course, this angle is congruent. So this is my definitely 5. Now I will write in triangle ABD and triangle PQS. AB upon PQ is equal to BD upon QS. AB upon PQ is equal to BD upon QS. This is from 5. Fine. Also, angle ABD is congruent to angle PQS. This is actually the first statement I had done. Angle ABD congruent to angle PQS. ABD congruent to PQS from 1. So I will write, therefore triangle ABD is similar to triangle PQS by angle criteria. Therefore now you have got what? You have to therefore AB upon PQ is now equal to, now you have got AB upon PQ is equal to BD upon QS, but it will be also equal to AD upon PS. AD upon PS. Fine. Corresponding parts of similar triangles. AB upon PQ is equal to AD upon PS. This will be your 6. Now you will again bring it to notice. Again, now you have to reach over here. Area of triangle. Now triangle ABC is actually similar to triangle PQR, right? Triangle ABC, this is given to you. is similar to triangle PQR. This is given to you. So what will I write? This is given by ratio of areas of similar triangles. Area of triangle ABC upon area of triangle PQR is actually equal to AB square upon PQ square. But then you have proved that AB upon PQ is equal to AD upon PS. Therefore, from 6 and 7, we get area of triangle ABC upon area of triangle PQR. This is equal to AB upon PQ is equal to AD upon PS. AD square upon PS square. That is what we have proved. Ratio of areas of similar triangle is equal to the square of the ratios of their medians. Hence, proved. Okay, my dear students, so this is again, we have finished with 6th question, and now we go to 7th question. 7th question, prove that the areas of an equilateral triangle described on one side of a square. This question is really very nice. This is a very old question, my dear student. I like this question very much. This is very old question, and it has been, means the textbooks keeps on changing, but this question has never vanished. It has always continued. Prove that the area of an equilateral triangle described on one side of a square. See, there are two equilateral triangle that you are drawing. See, definitely there is a square. What are they telling? Area, prove that area of an equilateral triangle described on one side of a square. Described on one side of a square means drawn on that square. Of course, then when you draw an equilateral triangle on the side of the square, so the equilateral triangle, we have all the sides equal to the side of that square. Fine. Is equal to the area of equilateral triangle. Whatever is the area that you draw over here, it will be equal to half the area of equilateral triangle described on one of its diagonals. Means you are actually going to draw two equilateral triangles. One equilateral triangle will be on the square, side of the square. Fine. This is A, B, C, D. This is your B, P, C, supposing. This is one equilateral triangle that you have drawn on the side of a square. So of course these sides of equilateral triangle will be equal to the sides of the square. This triangle which is drawn on the side of a square is equal to half the area. The area of this is equal to half the area drawn on the diagonal. Means any diagonal you can take. You can take this diagonal, you can take any diagonal. If I take this diagonal, and on this diagonal if I draw a equilateral triangle, that is the problem now. Like this it will come something like that. Q. The area of triangle PBC is equal to half the area of triangle QAC. This is what you are going to prove. And for this, the very important property, which actually is really very important, remember, for a square, this you have to remember, for a square, this is the formula, diagonal of square is equal to side root 2. Side root 2. This is the formula. Diagonal of a square is equal to side root 2. So in this case, if this is the square and this is the diagonal, so AC is equal to side root 2. So I can take AB root 2, I can take BC root 2, I can take DC root 2, I can take AD root 2. But because I am dealing with this triangle, I will tell AC is equal to BC into root 2. This is the very important property that you have to use. That's all. Otherwise, this question is really very, very, very easy. So basically this diagram, I hope you all have understood. So this is basically a square over here. Fine. On this square, I am supposed to draw two triangles, one on the side of the triangle and another on the diagonal of the triangle. Fine, my dear students. So it will be something like this. It definitely comes close anyhow you draw. So this will be your A, B, C, D is a square. Then given you will have quadrilateral A, B, C, D is a square, and you will have triangle B, P, C is equilateral triangle definitely, and you will have AQC, triangle AQC is equilateral triangle. That's all. And then to prove area of triangle PBC is equal to half area of triangle AQC. Understand the question properly, my dear student. Baki, it is very easy. It is very easy. See, basically what happens. First of all, what do you talk about triangle PBC and AQC? How will you prove them? Similar. Tell triangle BPC and triangle AQC are equilateral triangles, right? This is given. Therefore, triangle BPC is similar to triangle ABC. Bas, two equilateral triangles, two squares, two circles are always similar to each other. Fine. So this is there. So this is there. And now what they are asking me to prove? Only the ratio of areas. Na? So basically here then I will get by ratio of areas of similar triangles. So this you have to bother only why? Because there are two properties of ratio of areas of triangles. So only ratio of areas of triangle will be equal to b1 into h1 upon b2 into h2. Means area of triangle 1 upon area of triangle 2. Means half into base into height of first triangle upon half into base into height of the second triangle. Otherwise, you will have to see whether they are similar triangles. Then the scene will change. It will be equal to side 1 square upon corresponding side 1 square. Side 2 square upon corresponding side 2 square. So here we will be using the same corresponding side 1 square. So you will get area of triangle AQC upon area of triangle BP. Actually, I will better take BPC up because it is a required up. Area of triangle PBC upon area of triangle AQC. Now you will take what side of a square BC upon diagonal AC squares. Okay, sorry. So this is there. So you have got it now. Now what? You only have to remove, you have to find the connection between the two. Now AC is equal to, diagonal is equal to side root 2. Now we know diagonal of square is equal to side into root 2. This is by formula. Therefore, diagonal here is AC will be equal to side here is BC root 2. Fine, are you getting? But we want what over here? AC square. So AC square will be equal to what? BC square, and root 2 will become 2. Fine. So from 1 and 2 we get what? Area of triangle PBC upon area of triangle AQC is equal to BC square will continue. Instead of AC square, I will write this thing BC square into 2. Definitely now my BC square will get cancelled, and what stays back is area of triangle PBC is equal to half area of triangle AQC. I am shifting this AQC over here. Hence proved. Okay, my dear student, very easy. It was very easy, but of course you have to only know the formula. That is very, very, very important. If the formula is not known, then you will be lost. Okay, so now we are into the last step. Tick the correct answer and justify. Basically, justify also they have to. See here, ABC and BDE are two equilateral triangles such that D is the midpoint of BC. See, basically they are the equilateral triangles. So again it will be same. Equilateral triangles, so ABC will be similar to BDE, but don't know for what correspond equilateral triangles. No need of maintaining correspondence every side, because they all are congruent sides, so they all will be in proportion to each other for any correspondence. And for angles are also going to be 60 60 60, so then correspondence ka maintenance ka jhanjat nahi hai. But definitely, but here one thing is there, such that D is the midpoint of BC. D is the midpoint of BC. Ratio of the areas of triangles ABC and BDE. So here basically what happens, my dear students, BD is the midpoint of BC. So if I take, ये तो कोई equivalent triangle होगा नहीं अभी. If I take midpoint of BC, so BC will come over here. If this is AC, now this is my D, ABC and BDE. Now my BDE, E can be anywhere, I suppose. E can be here also. Then it will become my favorite triangle. But then the problem is that E can be here also. But I don't think it is going to make any difference. Whatever said and done, whether the figure is this, whether the figure is this. See here, triangle ABC is similar to triangle, now let us see, BDE. This is given. D is the midpoint of BC. Ratio, now what are they asking? Ratio of the areas of triangle ABC and BDE. Basically they are similar because they are equilateral triangle. This you don't have to show, because triangle ABC and triangle BDE are equilateral triangles. This is, therefore triangle ABC is similar to triangle BDE. Now by ratio of areas of similar triangles, I will have area of triangle ABC upon area of triangle BDE will be equal to, I can take now BC I will require and BD I will require, right? BC square upon BD square. Fine. Triangle ABC and BD, to ABC up and BD down, right? Are you getting? That is why I needed this diagram. But I can take, see, even if I take this figure, it will be BC square upon BD square. Even if I take this figure, it will be BC square upon BD square. This corresponding side is not going to change in any way. Definitely, if it AB square upon BE square for this figure, AB square upon BE square for this figure also, है ना? AC square upon DE square for this figure, AC square upon DE square for this figure also. It is not going to make any difference. Okay, so but at present we are concerned with only BC square and BD square, and here but D is the midpoint of, this is your one. So D is the midpoint of BC, therefore BC, you can take any, BC is equal to 2 BD or BD is equal to half of BC, but I will take BC is equal to 2 BD. Now here BC is equal to 2 BD. Reason, property, midpoint property. Fine. D's midpoint is given. So therefore I will get BC square, because there is BC square over here, is equal to 4 BD square. This is my second. So from 1 and 2, what do I get? From 1 and 2, we get what? area of triangle ABC upon area of triangle BDE is equal to BC square will, no, I have got BC square is equal to 4BD square, 4BD square upon BD square. This both will go, so you will get area of triangle ABC upon area of triangle BDE is equal to 4:1, 4 upon 1. है क्या उधर? Yes, we have got it. Fine. So 8th one also is done, my dear students. Now let us go to the 9th one. 9th one इधर ही कर लेता हूँ because only you have to take it. Sides of two similar triangles are in the ratio 4:9. Again it is a similar triangle and the sides are given. Areas of these triangles, now we have to find the area. It's very simple right here. So here what will happen, triangle ABC is again similar to triangle PQR, you can tell. You can take anything now, no problem. So by ratio of areas of similar triangles, area of triangle ABC upon area of triangle PQR. Sides of two similar triangles are in ratio 4:9 is equal to AB square upon PQ square. That will be equal to AB square upon PQ square means 4:9. 4 upon 9 square, that will be equal to 16 upon 81. This will be the ratio. Yes, 16 upon 81. So D is the right answer. Okay, here C is the right answer. So that's all, my dear students. This is again very important, of course. Nice one. 6.3 tak we had a nice time, gala time, all easy questions, easy solutions. 6.4 also is definitely very easy. Only thing is that you will require some amount of practice. You can't take it that lightly as everything was flowing in till 6.3. Okay, my dear students, so practice well, do well. I think you will be having solutions and everything with you. I'm thinking about, can I make these things available for you and people in some or the other way. I'm maintaining them. Let us see if I can make them available in some way. Okay, my dear students, enjoy geometry, solve this properly. Soon we will have to go into 6.5. Okay, my dear students, definitely it's not that difficult to start with, but slowly, steadily it will show its colors also. Boards है भाई, कुछ तो करेगा ही ना, बाकी कुछ नहीं, गुदगुली तो करेगा. चलो, have a nice time, dear students. Love you all.